Off-Campus Lunches by Victoria Sokolov and Tyler Rook. We decided to research if students who go off campus for lunch spend less money than those who get lunch for $7 in Kahila. We predict that students who go off campus will spend less money on lunch. The null hypothesis would be that there is no change in the amount of money spent on campus and off campus. In other words, off-campus lunch would have a mean of $7, so we write that mu equals 7. Our alternative hypothesis is that students spend less money on off-campus lunch. So we write that our null hypothesis is mu equals 7, and our alternative hypothesis is that mu is less than 7. The process. We randomly selected 40 Kahila students using a simple random sample, meaning that from a list of all of the Kahila students, we randomly chose 40 without bringing gender or class into account. We used 2 surveys. The first survey asked several questions, one of which was, do you go off campus or to the JCC at lunch? If their answer was yes, often, they qualified for the second part of the survey. The second survey served to find out how much a subject spent on their most recent meal off campus. The results. Of 19 students who qualified for the second survey, they spent an average of $5.63 on lunch. This is a bimodal histogram. It peaks at both $3 and $7. With no outliers, it has a standard deviation of $3.09 and a range of $9.14. The histogram has no symmetry. This is a 5-number summary which helps us understand the spread of the data. The t-value equation. We use this statistical test to compare our sample populations and determine if there is a significant difference between their means. The result of the t-test is a t-value. This value is then used to determine the p-value. In this case, we use the values that we calculated and plug them into the t-value equation. X bar minus mu divided by the standard error, which is s over root n. It equals the t-value. In this case, x bar is our estimated value, mu is our original mean, s is the standard deviation in the data, and n is the population size. With this calculation, we find that the t-value is negative 1.88. We then measured how much area was left underneath the t-value, thus finding our p-value. The p-value turned out to be 0.038. The p-value, the probability of observing a value for a test statistic at least as far from a hypothesized value as the statistic value actually observed, if the null hypothesis is true. A small p-value indicates either that the observation is improbable or that the probability calculation was based on incorrect assumptions. The assumed truth of the null hypothesis is the assumption under suspicion. In this case, we conclude that with a small p-value of 0.038, that we reject the null hypothesis. There is evidence to suggest that the average student will spend less money on lunch if they were to go off campus than if they were to stay for the cafeteria lunch that costs $7. Thank you.